Prove Mayer relation Cp minus Cv equal to R. Cp specific heat of gas at constant pressure. Specific heat of gas at constant pressure. Cv specific heat of gas at constant volume, and R is a gas constant. Then Mayer relation is Cp minus Cv equal to R. And value of R is this 8.31 joule per mole per Kelvin, or 8.31 into 10 to the power 7 erg per mole per Kelvin. Now question is state first law of thermodynamics, and on the basis of this law prove Cp minus Cv equal to R. This question can be stated as establish a relation between the specific heat of a gas at constant pressure and at constant volume. Now we will see the first law of thermodynamics. A system, if a system is capable of doing an external work, then the net amount the net amount the net amount of heat energy given to the system is equal to the sum of the energy spent in doing work by the system and the increase in internal energy of the system. Internal energy and work done. If the amount of heat absorbed by thermodynamical system is delta Q, and due to it the work done by the system is delta W, and increase in the internal energy is delta U, then by the first law of thermodynamics, delta Q equal to delta W plus delta U. Total amount is distributed to work done and internal energy. Now relation between Cp and Cv. Let 1 mole of an ideal gas 1 mole of an ideal gas be given an amount of heat delta Q at constant volume, so its temperature increases by delta T. Amount of heat is given delta Q, then temperature increases delta T. Now delta Q equal to ms into delta T. M is mass, S is specific heat, and temperature difference. Then delta Q equal to ms 1 mole gas. We have taken 1 mole, then 1. And specific heat at constant volume, that is Cv, then Cv into delta T. Now this delta Q equal to Cv into delta T. This is equation number 1. Since the volume of gas remains constant, therefore no external work is done by the gas. If volume constant, then no external work. Then delta W equal to 0. By the first law of thermodynamics, delta Q equal to delta W plus delta U. Delta Q equal to delta W is 0 plus delta U. It means delta Q equal to delta U. From equation first and second, put delta U here. Then it will become delta Q equal to delta U CV into delta T. This is third equation. Let 1 mole of an ideal gas be given an amount of heat delta Q at constant pressure. This is in constant volume, and now we are taking constant pressure, so that the temperature increases by delta T. Then delta Q equal to 1 into Cp into delta T. One into Cp into delta T. If delta V be the increase in the volume of the gas at constant pressure, then the work done by gas is delta W equal to P into delta T. Work done equal to force into distance. We multiply by area and divide by area. Then it will become force upon area into distance into area, that will be volume. Now force upon area, that is pressure. Then pressure into volume. Work done, that is pressure into volume. Pressure into volume, delta V. Delta W equal to P into delta V. Now from first law of thermodynamics, delta Q equal to delta U plus delta W. And just we have find at constant pressure delta W equal to P into delta V plus delta U. This is equation number 5. Now by equation 4 and 5. Now this is equation number 4. Delta Q equal to 1 into Cp into delta T. And 5 is this. Then P into delta V plus delta U is equal to Cp into delta T. Put this value here. Cp into delta T. Cp into delta T. Now putting the value of delta U, then P into delta V, and delta U is Cv into delta T by equation 3, by first condition, that is equal to Cp into delta T. Now this will transfer here. Then Cp minus Cv into delta T common is equal to P into delta V. This will transfer and delta T will common. Now this is equation number 6. In case of ideal gas equation, PV equal to RT. PV equal to RT, it means P into delta V is equal to R into delta T. A small change in volume, a small change in temperature. Now putting this value P into delta V equal to R into delta T here, this equation number 6. Now Cp minus Cv into delta T equal to, it will become R into delta T. Put this value here. Then delta T and delta T cancel out. Then Cp minus Cv equal to R, which is the required expression. And this is Mayer's equation. And R is the gas constant and its value and unit is given.